You coming?
All right, hello everyone. Honey, can you close the window? The birds are loud outside. All right. Hello everyone. We got a good group here already. More will be joining in.
Sorry.
Hope I sound okay. We're kind of changing microphones around. Thanks for showing up. Thanks for tuning in. We going to talk about a lot of different dataless things tonight. I have a history of being really long-winded, so my wife's going to try to keep me on a good time frame. I may ramble a little, but I just want to say Merry Christmas, Happy Holidays, everybody. I know things are kind of different this year. A lot of the community has been done over Zoom and FaceTime, and I know a lot of you guys aren't seeing your families, and so I just really appreciate everybody being here. This is Daedalus. This is my company, mine and my wife's. We started it back in 2018, and when we started out, it was kind of like a challenge. My wife said, we got a lot of engineering background, and we were getting into buying electric spinners, and my wife said, she was showing me different stuff, and I said, I like this, but I don't like that, and I like, and I said, no, I could just build one. And she said, well, why don't you go ahead and do it? And so I did. And the way it actually ended up was, this is going to roll into Raven. All right, so the Raven project is as old as Daedalus is, because my original intention was to use 2 electric motors. And as an engineer, I had all types of confidence, but I didn't know a lot about spinning yarn. And so I built a prototype, and I got it to perform, but I was never happy with the fine details, the finesse, the subtleties. For the first time in my life, I experienced humility. I realized I can't go forward with this because I can't make it I'm just not smart enough. I'm not experienced enough. I need to know more. And so I learned how to spin. And after I learned how to spin, I built a conventional electric spinning wheel, Blackbird. And so Blackbird is just one motor. It was Irish tension, and so the motor drove the bobbin, and the flyer is what's resisted, and it was a hit. People really, really liked it. And I was kind of hesitant for the business to take off, and before I knew it, it kind of had. And then we had a bunch of orders for Blackbirds. And so then I said, well, I got feedback. I listened to the people that I knew were more experienced and more intelligent than me in the community. And the feedback that I was getting on it, stuff they liked, stuff they didn't like, here's another type of spinning that this can't do that people would love to do. And so I just tried to just soak it all in. And I ended up building Starling. And Starling's a huge hit. It's a light Scotch spinner. The new V3 version of the Starling actually does Scotch and Irish. I consider it small-sized. It's easily portable. It was a big hit. And so Starling, I made a lot of Starlings, and I listened to the feedback, and that's why we're on V3 now. We've got a more powerful motor, higher speeds. Even though most people don't get over 60%, it's still got that room and that performance to kind of satisfy people that are faster spinners. This whole time in the back of my mind, Raven with the 2 motors. And so constantly I'm feeding stuff into that project, and I'm adapting the prototype, and I'm spinning on the prototype, and I'm trying to get it to where it's where it needs to be. And today's the day. I've been working with this specific version of the prototype for about 6 months, and the bench testing and feedback that I've got on it is fabulous. It does absolutely everything that I wanted it to do, and I'll get into those details in a little bit. But just historically, this is emotional for me because this is realizing where I wanted to be with the company and the product that I really wanted to produce. And it's here. So let's talk about Raven. Raven is the same footprint as the old Blackbird size. So you can see it here on the table. We've got a nameless little wheel. We've got Starling V3, Raven with the dual motors, and my largest and really highest performance wheel is the Magpie. Raven kind of does things that the Magpie can't do. It's kind of hit or miss, or their functions are a little bit different, but I think you're going to like it. Raven comes in at the same weight as Magpie. It's 2.1 kilos, which in American that would be about 4.5 pounds. Yeah, 4.6 maybe. So it weighs almost exactly the same as Magpie, but yet a smaller, more compact chassis. The bobbin capacity is probably in the ballpark of about 16 ounces. It's always hard to quote a bobbin capacity because different people spin different gauges of yarn. They pack it with different tensions and different tightnesses, and even the fiber itself. And so the ballpark on it, like I say, I'm shooting for the pound ballpark. Its RPM is going to be right in line kind of with Magpie in that 2400 RPM range, which I think most hobby spinners max out. In my experience working with people, probably around 1200, 1400 RPM. Production spinners, they're the ones that go for the higher speeds and the higher tensions. And like I say, that's why all of these are going to be capable of that. Raven is an interesting wheel for a couple of different reasons. It's not just that it uses 2 motors. The bench testing that I've done historically on Raven with the 2 motors has been with what's called an electromechanical solution. So basically I use resistors and rheostats and potentiometers, electrical things, to basically put it on a knob so I could kind of control the speed of the rear motor, or what the rear motor was actually doing with a knob at any given time. And that was frustrating for me. I just knew it wasn't going to go over. I knew it needed more refinement than that. It turns out that with all my testing, it's very, very intricate what that rear motor has to be doing at any given time. When it's starting up, when it's running at speed as you're adjusting the tension, and then when it's shutting down, that rear motor has to have a personality that's going to work with you. And the only way I could get that achieved was through microprocessor control. What does that mean? That means like your smartwatch, your smartphone, or any little device that's got a screen and buttons on it. It's basically got a tiny little computer chip in there that is always watching sensors, like the speed of the motors and the temperature of the motors, and the electricity going to the motors, all different types of variables. And it's making decisions on the fly, like hundreds of times a second, as far as what that rear motor is going to do in relation to what the front motor is doing. And that's the point that we kind of are in the project. What you see in front of Raven is a mock-up. I've got the components downstairs, and that's what we're working on the bench testing at this point, is we're putting together the speed control to control the machine. It'll be a touch screen, so just like your phone. It's real size there, so it's a 5-inch display, and it'll give you all types of flexibility. It's simple and sophisticated at the same time. And that's the stage that I am in the project. I've got a good prototype running. I'm working with the components and really the algorithms that control, the programming algorithms that control that rear motor for what it's doing at any given time. Those are what's being refined now. And so I've already proven the functionality of it. So let's talk about that for a moment, the functionality. David, why do I need a spinning wheel with 2 motors? All right, so the rear motor is basically your tension. So it provides the same service as the friction belt or tension belt and knob and screw and spring setup that almost every spinning wheel to date uses. There's nothing really wrong with that tension belt system as far as it's been used for forever. It works great. But there are kind of some weaknesses in it, namely, like with an electric spinner, if you go to repeat a project, you spin a project, 6 months later, you repeat the project. The only 2 inputs into the machine are the speed and how much tension you're using. So with an electric spinning wheel, some of them have knobs that you turn 1, 2, 3, 4 up to 10, and you got to remember, well, I'm a 3.5 or a little bit in there. Well, I went a step further, and I use digital speed controls that give you between 0 and 100% adjustment. So if you go to a 67% speed, 6 months down the road, you bring it back to 67, it's running that same speed as it did. So the consistency to be able to repeat those projects is fabulous with electronic speed control. The tension system, though, is still kind of the same old-fashioned one with the tension belt. And that means it's up to you. You've got to turn the knob and get the feel of the uptake, or how much draw it really wants to put into the yarn. You've got to do that yourself. And so you've got to dial it back in to be the right feel. And that's hard to get perfect every time. With Raven and a rear motor turning the bobbin, or actually resisting the turning of the bobbin, acting like your tension system, you can numerically adjust your tension on the display. And if you set it to a tension of 87, and 6 months down the road, if you bring the project back, you can ask for tension 87, and that yarn is going to pull onto the wheel exactly the same as it did 6 months ago. So now your consistency between projects is flawless. Does that matter for everybody? Yes and no. The more serious you are, the more time you spend spinning, the more you repeat projects, I think that's more and more important for you. The real beauty, the one, I hate to say trump card, but the one trump card that the dual motor has is that it's capable of zero take-up. And that's really, really hard to get in a conventional tension belt design. In other words, even if you take the tension belt off of a normal spinning wheel, there are going to be forces, frictions, aerodynamic drag. There's going to be all types of things that want to lag that bobbin behind the flyer. And that creates a little bit of take-up. Is that important to 90% of you? No. There's about 10% though that fall into a category that are high speed, low tension. And what that means is you're going to use that technique for really short staples. I work with a lot of different spinners, and some seem to gravitate towards that end of the spectrum. Long Draw James. He's my tester for actually that mode of spinning, because he spins really high speeds and really light tension so that he can part a lot of twist in every inch for how fine of a gauge of yarn he's spinning. And some of the staples he spins are really short. In a tension belt system, you almost never can get to that point. When you have two motors, you can kind of choose how fast that rear motor's spinning, and you can actually dial it in to where that motor's spinning the same as the flyer. If the bobbin and the flyer are spinning the exact same RPM, that's where you have zero take-up. That's useless for spinning, but that means that if you can provide zero take-up, you can provide a smidge, 1% from there, to where it's barely perceivable. To be able to have resolution to adjust that feature in that range from zero take-up to very light, and to be able to control it digitally to repeat your project every time perfectly, is something that a dual motor spinning wheel can provide that the tension belt cannot. And so that's one angle that I wanted to go after this as well. Do you have to spin that way on this wheel? No. You can turn the tension up and turn the speed down to whatever you're comfortable with, and spin all different types of gauges all day long. How thick can you go? I would be kind of guessing at this point. I actually have an orifice reducer in the end of this. This is a 6 mil reducer, but it opens up to 20, which is kind of halfway between here and here. So it's not limited on the orifice size. It's really going to determine, I can't give you a specific answer right now, because bench testing, I'm all about testing. And whatever the final production release will be, I'll give you the goods on that. But right now, it would be perfect. It's not an art yarn spinner. Can you spin art yarns on it? Yes. You can spin. You can core spin, you can do some thick and thin. There's all different types of art spinning that you can do on this, but when I use the term like an art yarn, I typically mean like really heavy, weird, crazy stuff. Like this actually has LEDs on a wire that have been fed through it too, which is unusual, but it's not that heavy of a gauge. Long lock spinning, tail spinning long locks. There's all different types of really heavy textured art yarns that you see. And that's still going to be in the ballpark of Magpie with the art head. It has the power system and the gear ratio and the speeds and the yarn path and everything to allow you to do that. Where Raven is a little bit truncated down from there. Like I say, you can flirt around with art spinning. Obviously, it's going to do a lot heavier stuff than Starling would do, but it's not going to get anywhere close to Magpie on the art head. So that's pretty much Raven. I know I'm going to take all your all's questions at the end. I know if some pop up in the group, my wife's watching it and she's noting them down. But at some point, I'm going to shut up and I'm going to actually address you guys. The last thing I want to say about Raven right now, I came up with an interesting number last night. I've been a little bit obsessed with this idea for the past couple of weeks. The weight of the motor. Now, I understand I'm risking boring you all to death with this, and so I'll try to be pretty quick. But electric motors are a little bit shady, the way that you say how powerful is your electric motor. And there's all different ways I could say things to make it sound bigger or better. And so I was trying to think of a way that you could just make it cut and dry. Like, what is the best numeric that you could assign to the motor so that you could kind of compare them? And the number has to do with torque. So power in an electric motor really just has to do with how fast it can get accelerated or accelerate a load. It's like how fast can the bobbin come up to speed? Well, that really doesn't matter because our speed controllers have separate soft start and soft stop delays that have to be used that kind of let it start up slowly and stop slowly so it doesn't spit yarn off or yank it out of your hands when it starts up. And so to have a super powerful motor, you don't really want it. You don't have to get that thing up to speed super fast. What you want is once you get it up to speed, you want it to be able to continue working against a load at that speed. And that's where the torque of the motor comes in, which is a whole nother characteristic of motors. The one thing you can look at with motors and try to figure out how they compare in torque is the weight of the motor itself. The heavier a motor is, generally speaking, the more torque it has. And so in all my designs, I try to stuff as much motor as I possibly can in there. And so I weighed the motors in Raven, and I weighed Raven with the motors. And what I discovered was the motors weigh more than half the weight of the whole machine. Because it's made out of carbon fiber and lightweight 3D printed ABS parts, the chassis itself is very, very light, and the motors are very, very heavy. You combine those two factors together, and it's pretty reasonable. I think it's light on the whole spectrum, being 4.5 pounds or 2.1 kilos. I still consider a pretty light wheel. So I think that's just an interesting little factoid that Raven actually has more motor than it has spinning wheel in it. All right. So I'm going to move on now, and I'm going to talk about this little guy. I know I released some pictures, and I got a little bit of buzz started. What is it? Why is it? And how the heck can I get one? This is Sparrow. So this is my second release that I'm going to do this year. Sparrow is doing great. You can see that it's a scaled down. It's not exactly a scaled down Starling. It uses the same proven mechanics and design. I still use the same type of axle, which I think I'm the only one that uses linear rod, like true linear rod for the axles and good bearings and all that same hardware just scaled over. So it's still quiet, it's fast, it's 2,000 RPM compared to 2150 compared to 24. 2,000 RPM again is great for the vast majority of you out there. It's smaller. What were my other goals? I wanted it to be cheaper, and just so it could be more accessible to more people. I understand the Starling kit coming in at $950. It sounds like a big wallop, but it was designed to be a forever tool and to be as flexible and friendly to you and as dead quiet as possible, so you'd enjoy using it for many years. But that's still a big chunk of change to write, and I thought that if I could scale it down to save money so that I could offer it at a cheaper price, I would be willing to do it if and only if I didn't cut any corners. You know, like, oh, well, this thing makes it perform well, but it's expensive, so I'll have to use something cheap. And so I really didn't want to cut any corners, but I basically just tried to scale everything down. And so I took the motor that's in Starling and scaled it down a notch. And because the head is actually smaller, Starling is about a 12-ounce bobbin, and Sparrow's going to come in at about a 6-ounce. So because it's a smaller head, the smaller motor, it works with it about the same way as Starling. So that's why I say it's kind of in the same speed category and performance category. It comes with the same digital controller that Starling does. So you have the same flexibility. It's not a 1 to 10 knob for your speed. You literally have 0 to 100 digitally, and soft start and soft stop separately that you can adjust in that controller. So no matter what speed you spin at or how much yarn's on your bobbin, you can always make this wheel work really well with you. Our introductory price point is going to be $510, and that includes the controller. All right. For those of you that have already bought a Starling and you want to use the same controller that came with your Starling, you can get this wheel without the controller, minus the money that I charge for the controller, which is $110. So you can buy just the wheel with no speed controller, use it with your existing Starling as like a travel wheel. I mean, Starling travel's great, But if you're looking for something even smaller, taking the car with you to lunch, what have you, you could buy the second wheel for $400 and use it with your Starling controller. And I think that's a fabulous deal, actually. It has all the same features as far as the pivoting flyer, so you can change your bobbins without having to mess with your drive belt or anything like that. Carbon fiber flyer arms. It has the same carbon fiber tube chassis that the larger wheels do, just a smaller size carbon. So again, that's where that piece of carbon didn't cost me as much. I'm trying to carry those savings on to you. And they're still a fun build. They go together a little quicker where they're a little smaller, and so that helps too with trying to keep the price down. And so I wanted to bring it out and I want to introduce it. There's a lot of wheels that are out there in that 4 to 6. It seems like treadle wheels were always just 4-ounce bobbins, and so to have a 12-ounce is just a hulk. And so I said, well, here's something that I think people can use. With being a 6-ounce bobbin, again, it's kind of odd depending on the gauge that you're spinning and how tight you pack it. But I feel comfortable that you could get a 4-ounce skein on it, even if you were spinning a heavier single gauge, like maybe a DK or something like that. It wasn't really tightly packed. But a lace weight with a good, nice, firm, level pack, 36 wraps per inch, you're probably in that 6-ounce ballpark on it. When will it be available? How will it be available? It is in the test spinning phases. And so the prototype's been verified as far as function. We've gone through some test spinners and had some ergonomic changes as far as knob design and little things like that. And so it's really ready. I'm putting some little polishing things on it. Basically, there's some small aesthetics I'm not completely happy with. And so really I'm just going to put lipstick on it and it's going to be ready for sale. I'm shooting for the 3rd week of January, which is going to be somewhere between the 15th and the 22nd, maybe. I don't know, but dataless and shooting for, sometimes that can get a little weird. But I don't see any obstacles with this guy, and so I want to go ahead and get it out. What are its capabilities? Even though it's 2,000 RPM, you can see the gauge or the size of the orifice. It's a 6mm orifice, which is the reducer size in Starling. Now, whatever you can do in that 6mm orifice, this wheel can do. Is it going to be an art yarn spinner? No. you can obviously see that. Is it only just for lace? No, absolutely not. I think it'd be perfectly comfortable spinning a sport or a DK single. You could probably ply up to, I'd say easily an Aran, depending on how tightly you want it packed. I think Aran ply is kind of going to be where that breaks over and where you're going to kind of need to step up. If you're going to do heavier yarns than that, you're going to need to step up. But if you're going to work from that scale down, and to be honest, most of the spinners that I communicate with, that's what they operate in. Their comfort zone is 20 to 36 wraps per inch, and they hardly ever do anything outside of that rather than just ply those together and make an Aran or something like that. So I think it fits a lot of you. It's a cheaper way to get into it. If you already have a Starling, it's a great little travel wheel. We're going to have custom colors. They're not going to be your choice of color. The whole palette's going to be there, but as far as what pieces on the wheel you can choose to be trim or colored what, we're still kind of working that out. Obviously, you can choose a main color, and I'm not sure exactly about how the trim colors are going to work out yet. This one's technically trimmed in black, so it's kind of a bad example. But there will be, I believe there's going to be 2 color choices, a main color and a trim color. We're just sorting all that stuff out. Give me a couple of weeks. So, before I move on to the questions, let me think if there's anything that I missed. There's a lot that I've missed, but I'm not going to go back and bore everybody to that. So let's start taking some questions. Excuse me. How do 2 motors offset the battery life? That's a great question. Just because it has 2 motors, don't believe that it's twice as powerful. I don't know if others are saying this, so please don't quote me as, correcting what someone else has said in the industry. But if your electric spinning wheel has 2 motors, in this configuration, one motor is basically driving the whole system, and the other motor is really just acting to slow the bobbin. The rear motor that's acting to slow the bobbin, when it's in that mode, actually doesn't really consume any energy. And so it's almost like it's free. And I could go into real boring detail on that, but I won't. So effectively, it's really just the one motor, just the front drive motor. That's the same motor that's in the Magpie. It's a honking big motor, and so it's going to have the exact same characteristic and battery life that a Magpie would have. The extra motor operating the drag in the back will not affect it in the worst case scenario more than 5 to 10% of its battery life, but more than likely it'll be 1 or 2. So it's so much that it would almost be hard to really measure. It might actually do a little bit better. So it's hard until I actually get it in the finished prototype, but it'll be very, very similar to what the Magpie does. The price point on Raven, wow. You caught me, right? I want to make this as cheap as I can because I want to get them out there because I think it's great. I really do. I believe in the product. What makes Raven different than my other projects is a stinking box up front. If you guys aren't familiar with the process, you find an electrical engineer, you have a map of a circuit for you. I know just enough in that field to be dangerous. They breadboard it, you go back and forth with prototypes, you find a company, they'll convert it to a PCB, and then you find a company to make you those PCBs, and then you got to prototype the PCB. It's all done in batch, which means you don't just buy one, you got to like buy 100 or 500, and you're kind of guessing on it's going to be right or not. And then you got a software guy that writes, which is me actually in this case, that writes all the code for it. And that, if your programmers out there, you know, the debugging process on something like this can be an absolute nightmare with closed loop control systems, monitoring sensors, and acting in real time. And so the price for me, the cost of development is skyrocketing on this guy simply because of the electronic control. I will not sell this unless it has that, because this is the single thing that makes this viable. Without the microprocessor controlled speed controller, it's not the same product. It's neutered. It can't do what it should do, and it'll be ugly about what it does do. And so I'm definitely pushing this through, and this is definitely going to happen. But man, it's just been a hard uphill fight. You got to imagine I'm building wheels to fill back orders, trying to design things for the future. I'm trying to work on those projects. I'm trying to balance all these different jobs, and I've been squeaking time in on this, and it's here. And I'm ready. The fact that I'm talking about it means that it's passed enough tests with me that I know it's going to do what I say it's going to do. So that was a long way for me not to answer your question. And $1,600 to $2,000. I don't know. I'd like it to be on the bottom end. If it turns out that the programming, I can get the programming done and I can save that money, I'm going to carry that on to you. If it can't, and I've got to go out and outsource to these other people, and the project runs up in costs, it might go up from $1,600. But I'll know better as time goes on. As this evolves, which is going to happen in the next couple of months, I'm going to be able to narrow that price point in. And also, I'm sure this is a question, but I haven't gotten to it yet, but on that subject of when will Raven be available? It'll be available when it's perfect. All right? That's tough for me. All right? Because I'm sort of a perfectionist, and I sort of have OCD, and I can see me in a death struggle with the algorithms in that speed control. The fastest I can perceive it, on top of my workload and trying to provide for the people that have already paid me money and want their spinning wheels and deserve to get them, and my free time designing stuff like this and working on this, 2 months would be a miracle. And I believe in miracles. 6 months is more realistic because I just know how life goes. And it's not like other things would be distracting me. It's just life goes like I know how that's going to go. So 2 to 6 months, I hope to have this out on the market, but I'm not going to let it go a day before I'm completely happy with it. And that's going to take some doing. It's going to take a lot of test spinners, a lot of feedback, a lot of performance testing, a lot of torture testing. Yeah. All right, so I'll get on to the next question. As the bobbin fills, tension needs adjusting. How can you repeat a project? Okay. So it's not an automatic tension. So tension is going to be adjusted on the screen with an up and down arrow and read out numerically between 0 and 100 or 0 and 150. I got to work that out on what your tension level is. And so to repeat a project, you set speed 50, tension 77, whatever your notes were, whatever your project was, and it'll always have that uptake. Now, as a bobbin fills, you need to increase tension. That's with conventional spinning wheels. It's a matter of physics, basically. And there's no real getting around that. So basically, just like how as your bobbin fills, you'll reach and turn your knob to pull your tension down, your belt down a little bit tighter to get that tension back to where it was, you'll do the same thing on the screen. And you'll increase it a couple of clicks. So you might start your job at 77 and you might finish it at 85. So it's not, how smart can I make it? Could I make it do that for you? Man, I could take a stab, but I can't make it suit everyone. And so its personality in that regard could fight with some people. And I don't want to take that ability away from the user. It's your machine. You tell it what to do and it does it. And so it kind of falls into that category. So I hope that's answered your question. As the bobbin fills, you're still going to increase the tension manually, just you'll be doing it on the touch screen and not with a knob. Asking about brake band material. Yeah, okay. Brake band material. So effectively, instead of, on a conventional setup, I use rat tail, which is a really kind of like a braided nylon. Some people say it's silk and rayon, but I think it's a braided nylon. It works real well for those purposes, and that's a friction thing. So in other words, the bobbin's turning and the belt is static, and so it's always rubbing against it. I've had real good luck. People say, "Well, did you go to the two-motor design because you didn't want to have to replace your brake bands, or once a brake band wears out, then you have to replace it." To this day, I haven't had the first person wear out a brake band. I've had 2 or 3 people during testing and 100% high tension stuff. We've actually burned some brake bands off, but it'll actually burn off before it damages the bobbin or anything else. So it's kind of like a safety fuse. And I've only had that happen with 3 people during testing where I asked them to abuse my wheel. The whole rest of you, nobody's ever called me and said, "Oh my God, I've run out of brake band. Can you send me more?" And I actually send spare brake band in the kit, and I haven't had people say, "I had to get into my spares. Can I order new spares?" So the brake bands really aren't wearing. So that's not the reason for the change. The change to a dual motor, it doesn't use a slip system. It uses the same rubber belt that the front drive motor. So the flyer is driven with a rubber belt. The bobbin is driven with a rubber belt all at the same time. Those rubber belts last forever. That's another thing. I've had 3 belts break, and it was within 2 weeks of the user getting it. What happens, sometimes you'll get a void inside the splice that you can't see. But if you do, it'll always work itself out within the first 10, 20, 30 hours of use on the wheel. Outside of that, I've never had and I send them, you get a spare in the kit, put your spare on, I'll send you a new spare. Outside of those 3 people that broke like immediately right after they got the wheel, no one's worn out a rubber drive belt. No signs of wear. It's getting thin. It got stretched. It doesn't work anymore. Nothing. I've made 1,500 drive belts, and I've had none wear out. So it's a great system. So we're using that on both sides with the Raven. So it's not a slip thing. It's not a tension belt. The bobbin is actually driven with a motor, just like the flyer is driven with a motor. Moving on. Why use ABS? Yeah, plastics, man. Plastics is a huge market. A lot of different plastics. Most of the plastics in your car, it's like the buttons and the little plastic shields and vents and stuff. That's all ABS plastic. It's tough. It lasts a long time. It's heat resistant. It's a solid plastic. There's some other ones out there that people will talk about, especially in the 3D printing industry. But ABS has been a standard in injection molding for forever, and it's because they're just really, really tough parts, good plastic. PLA is the thing that people who 3D print, they start out printing in PLA. And PLA is polylactic acid. It's not important. It came out, it was invented in the 70s, and it was notorious because it had a really low melting point. And And that was great when 3D printers came out in the late 80s and the 90s. They said, well, we need a plastic. What do we use? Use a plastic with a low melting point. Hey, that way we don't have to work as hard to extrude it and print it out. It's great. PLA is great. When it prints out, it's actually pretty hard, pretty strong. But its weakness is the temperature resistance because that low melting point. Not only does it hit, they have what's called a glass transition temperature, which is used in 3D printing when it actually liquefies. But the worst thing about that is much lower than that temperature, PLA begins to sag when it gets warm. And when I say warm, I'm talking like temperatures in your car in the summer, in the south any time of year, and in the north, up north any time in the summer, your car can easily get to 120, 130, 140 degrees, and you'll start to notice deformation in PLA parts. You can search YouTube for PLA summer car or something like that. You'll see tons of videos where people print PLA, put it in their car, time-lapse video, like a melting snowman. So definitely no PLA. You wouldn't want to use PLA on parts that rub together necessarily. ABS is a little bit better for that. But in my designs, anytime there's a wear component, I try to make sure that it's metal. So like all the yarn path only touches steel. And so that, because even ABS can eventually wear down if yarn is dragging across it. And so that's why I use ABS. It's harder to 3D print, but it makes a solid product that lasts. And so that's what I'm into. All right, I've gotten a request to pick up Sparrow and show it off.
Dave, show him the flyer.
Oh. No, you can work it.
No, turn it from the front. You guys, look at this little flyer. Look at how sexy that little flyer is. I'm sorry, I've been looking at it all night.
I know.
And I was just whispering with Rebecca, I've got to show everybody. But yeah, look at that little flyer. I mean, is that not the cutest little... I just love the arms on it. So, okay, I'm done.
Yeah, no, you're cool. No, I appreciate that. That's actually the one detail about this machine that I had the most fun designing. And I was the most surprised when I actually put it on the bench and tested it out, because I expected it to draw a little bit more air than it actually does. And what I mean by that is I've got some aeronautical background, and so aerodynamics are really, really important to me, or I'm always considering that angle. And the swept arm, I did that for a couple of reasons. It kind of gets the arm out of the way for the yarn to come out and hit the guide. Just move the arm over and turn it sideways. But it's actually kind of aerodynamically nice, because if you're spinning something, if there's drag out at the end of it, it means more than if it's near the center. And so out at your flyer arms, that's where if you have a lot of drag, that's where the motor's going to have to work harder to overcome that. And that's work that you can't use the motor for. And so trying to minimize those drags is really, really important to me. And by sweeping that arm, it caused the outboard portion of it to be more in line with the airflow. And so, man, on the bench, it just tested out really, really cleanly. Doesn't throw a lot of air. And I think it's cute, too. I think it still has an organic feel, like it's not a real, what an engineer would typically build. So, thank you. Orifice size. On Sparrow, 6 millimeters. No reducer. That's ideal for your lace weights, but like I say, you can stuff heavier stuff into it. Plying is where you're going to be limited by it, and I think it's going to run out at about an Aaron. We'll see what it can do when we finally,
I really like that's the one wheel that you have that you could literally almost put in a little metal box and take with you on a plane without taking it apart.
Yeah.
You can put it in your purse and take it on a plane.
Yeah. Yeah, it's for scale. I'm not really sure the dimensions on it. Do we have it? Yeah, we've got 6 inches wide, 7 inches tall, 8 inches long.
Paula is correct. She says, good point, easier to use on a bus. And Paula, you're right. It is. You can totally use it on a bus.
Yeah, or like a glove box, dash of your car, depending on how flat it is. If you're really working on certain, or even I've seen people spinning the floorboard of their passenger seat. And so it's a perfect little travel wheel for that. Like I say, if you're not needing... If you fit that category where you're just a lace spinner and you're just throwing a few of those plies together because you're spinning your own stuff that you knit with, and you stay in that category and you're not worried about jumbos and bulkies and chunkies and all that stuff, you can go with this. What good would it be to spend the extra money to go up a Starling? Higher speed, more torque, a lot larger bobbin capacity. Instead of 6 ounces, you got 12 ounces. And you've got a larger orifice when you remove the reducer that you can do a lot heavier weight of yarn on it. So it gives you a wider range of ability and gauge and a higher top end speed. So that's why I say that's kind of the progression as we're going from left to right here. All right, how will you meet volume?
Like production.
Oh, demand? Oh, okay. Yeah. You know, my fear with Sparrow was that it was just going to drown me. And don't get me wrong, I appreciate the orders. I appreciate your all's loyalty, interest. It's everything to me. And I didn't want this to take away from everybody who's doing all of this. Okay? And I didn't want to become this maker. So at first, I'm not going to take orders for Sparrow. I'm going to produce them in batches. And so I'll have the first batch, like I say, ready by hopefully the 3rd week of January here. And I don't know how many is going to be in the batch. They're going to be assorted colors. So, and I'm going to just sell them outright individually, and we'll just see how that goes. And that way I can kind of control that on my workload to make sure that only when I've satisfied the people that already have orders and have already spent money with me and are waiting on a different wheel, when I'm done with that, then I can work on these. And that way I'm not robbing one of you to pay another. And so in that vein, I think if I'm going to release them in batches until I just see how production runs. There may be a point that I open up orders and start taking orders for them and getting them on the wait list. But at this point, I'm more concerned for my existing customers that I don't want this to infringe on them, and so I'm going to hold it back. So when I release the batch for sale, I'll give you guys plenty of warning. The Facebook group will notice first. Then I'll post it on Instagram the day that the sales will go live, and I'll have a set number, like I say, all put up, and when they're gone. And then maybe 2 weeks, 3 weeks down the road, if I can work in some time, I'll build another batch of these and put them up for sale on the website. Okay. Price point, again, $510 for Sparrow, but that includes the 110 controller. So if you already have the controller with Starling and you only buy the wheel without controller, you spend $400 on the wheel. That comes with 3 bobbins. Okay, I've done these. Now we're here. They just keep building up. This is great. Here. Oh my goodness. Where do I start? At the top of all these?
It doesn't matter.
Are the final guides on Sparrow hooks? What did you mean by that?
Just what I asked. The hooks, the guides are hooks.
Yeah.
Is that going to be the way it is?
Oh, I'm not exactly sure. When I said I want to put lipstick on it, like in other words, just fine aesthetic details, those guides are what I stare at every day. And so I'm going to sit down, I'm going to redesign them. They'll probably still have the hook if I can get away with it. Why did I do the hook instead of the wire? It's easier. It just goes together easier. With the wires, I custom bend them to angle by wrapping them around a thing. And so it just takes a lot of time for me, believe it or not, for me to do this and insert these. It's just more craftsmanship angle, and this is more of a wham bam, there it is, and it works great. Is there a drawback to it? You know, I couldn't really find one. Like, they're replaceable. If there was ever a day, like let's say you're spinning the dirtiest, I can't say alpaca, can I? If you're spinning sandy alpaca, by God, that stuff's like a razor blade. And if there ever was a case that you actually wore into one of these items, you could just screw it out and screw another one in. And so it's very simple to replace. Now the guide, I'll probably just send you a whole new guide. But like on the shoulder of the flyer, you wouldn't have to buy a whole new flyer. Or you wouldn't have to send it back to me to have the part replaced. I could just send you the hook and you can screw the hook in. And so I really like the hooks. They're not that bad aerodynamically. But I just got to make sure that for you as the user, like as I test spin on it, that there's nothing that perturbs me about it. That it fits my fingers well, and it moves well, and it does its job well. And as long as I get into that range, I think I'm going to be okay. So yeah, I'm going to struggle with the hooks, but when we get off here tonight, I'm going to be redesigning that guide. What about a kit for Sparrow? Holy. Who asked that question? Kick them off the group. I'd love to. I'd love to offer a kit. because that means I don't have to build it. And I love building them. But part of the price and the delay and stuff, it's time. You guys have to realize that even though I'm in this business, I operate different than a lot of the other companies that are out there because I am the sole fabricator. I'm not just the designer. I didn't come up with an idea and kick it off to Kickstarter and say, hey, honey, let's start cashing checks and let somebody else build these for us while we smoke cigars. I work hard every day. My wife, every day. It's nonstop. And so the idea of a kit, that excites me. I can print the parts. I can throw it all together, good instructions, if the process is right. The only hesitation I have is I have to make sure that how a layman would put it together would still have the dataless quality. And the dataless quality is it's damn near silent, it's smooth, it lasts forever, it does what it says it's going to do. If I can achieve that one day, I'll offer kits. Right now, no, because I tried to build the details into this to allow it to be assembled by a layman in a faster fashion. I'm not comfortable yet. So I'm going to build the first few batches. I'm going to send them out. I'm going to let my wife build some and see how that goes. And if we can get that system worked out, then there's a chance, yes, I will sell a kit at some point, but no promises. And don't hold me to it. And if you say I said it, I'll say you're a liar. All right. Lazy Kates, man. You guys won't stop. Okay, I got some axles in.
I agree with him.
I know. You're all right. You're absolutely right. It's murderous. I got some axles in. A handful, man. All I could get off the guy. It took me forever. It took me like 4 months. I want to design like a crazy Kate. All right? Like do everything this way. It can be this way. Can it be this way? Can it do 3 axles? Can it do 5 axles? What type of tension system can it have? It just snowballed into something horrible and ugly. And I made some prototypes.
I agree with that.
Yeah, right.
Guys, I tried to use it. It wasn't fun.
Stephanie at Deep Dyed Yarns was my Lazy Kate tester, and she pulled no punches.
I also had a lot of fun with the Blackbird.
Right.
How many times did I break it?
Oh yeah. You're on that list, the torture list. Lazy Kates. If I'm going to do something with it, it's going to be a 3-axle Kate that stands vertically. So it'll be a frame on the bottom and 3 vertical axles, and you slide the bobbins over them. Is it going to be a tensioned Kate? For me to get into that kind of makes it a lot more complex. I'm really leaning towards just making it simple so I can keep it cheap and be able to produce them and get them out to you faster and cheaper. If I do a tension system, it involves springs and threads and knobs and all types of weirdness, and also makes it more cumbersome to use unless you're really experienced with a tension Kate. And I'm not sure what road I'm going to go down, but keep your eyes open. I may start releasing some batches of simple Lazy Kates. That'll be 3 axles, and they'll only be vertical. They'll break down and pack real nice for travel, but I'm not making any promises about tension because I haven't come up with anything that I'm completely happy with yet. Will a module attach to the face of Raven like Magpie? It will not. Next question.
Is the Raven flat pack like Magpie?
Oh, is the Raven flat pack?
That's that one right there.
Oh, is it coming? Yeah, I'll go ahead and answer it. Technically, yeah. Yeah, it has the same attachment method as Magpie, so it'll come with a wrench. The bolts on the tubes are not bolted into plastic, so they're actually run through into what's called a square nut, and so it's an actual metal nut. So no matter how many times you take that bolt in and out, you're never going to wear out the threads. Where if it's a bolt into plastic, there would be a limited life before you wore those plastic threads out. And so it's set up with the same hardware as Magpie. So technically, yes, you can flat pack it. To this day, no one's contacted me and told me they flat pack their Magpie. I send them out, people use them as they are. The flat pack feature was like an afterthought almost, or it's just like along the way, like, hey, I might as well since you can. And I'm really not familiar that anybody necessarily has. Magpie's so large, it tends to be like a home wheel and doesn't really travel as much as the smaller birds do. But yes, to answer your question, it is flat packable. The module doesn't attach to the face. I'd have to make some compromises, And trying to shrink the chassis down from Magpie to Raven creates a lot smaller pockets that I'm working with to try to fit the electronics in. And one thing that I've learned along the way is if you don't provide space in your electronics, the person that's putting those electronics together is going to hate you. And so I like room. I hand solder all of my connections. There's no crimps, there's no slide-on connectors. Every connection is hand soldered through this thing. And so I needed room. I wanted a big display. If I've gone with a 3-inch display, or actually a 2.7, I actually had a mock-up that would have fit into that hollow. And then I just decided that if you're having to touch a stop-start button, adjust your speed, and adjust your tension, that was too many things to put to get that close together. And so I wanted more real estate so you could use it more easily. And so I went with the 5-inch screen. It kind of blew the idea out of attaching it to the face of the machine. And so no, it is completely separate. But it does kind of fit inside nicely for travel, or if you are traveling with it, it kind of fits inside. So I guess the Starlings do too. All right. Will the belt stretch? Yeah, I covered that. Quality urethane, I don't know, man. I see reports of people talking about belts that have stretched on treadle wheels. And are those urethane belts? Because quality urethane, no.
I can actually answer that.
Can you?
Over time, over years, with heat and environmental changes, just like any other plastic.
A rubber belt
Yeah.
will finally stretch.
Think of it as like a fan belt.
Yeah, okay. Sure. Yeah.
Yeah.
Although I haven't experienced it with any of my customers.
But it takes time.
Yeah, that's why I say I've only been in business 2-3 years.
Maybe a decade.
Right. maybe in a decade. So no, they don't wear by getting thinner. In my experience, none have stretched. I laughed. One of my torture spinners, I put a flyer arm or a flyer back on a Starling, and I did it a way where I kind of stretched the belt and lay the bearing. It's in the videos where I show you. And she was aghast. She was like, "Oh, I've never stretched my belt that much. I carefully lay it around the motor." I'm like, you don't have to worry about it, because there was a thing with the older Starlings. I had to use a rubber belt to squeeze carbon tubes around some leather that I was gluing. And so I used the same urethane that I use for these belts, and I just made a little bitty belt about this big around, spliced, okay? And I would stretch that thing like a bow. Like it took all of my hand strength to get that belt out and get it around that unit. I used the same belt for hundreds of wheels, and it never broke, it never stretched. They're amazingly tough if you get that splice right. And if the splice is not right, you're going to know real quick. So if it works for 2 weeks, it's going to last longer than I can imagine or perceive. All right. Don't try to move faster. I'm probably talking too much about these questions. How beginner friendly is Sparrow? It's exactly like Starling, because your interface with it is exactly the speed control. You set 40% speed, and like with Starling, I tell you how to ballpark your tension, how you'll rotate the hook to get all the slack out of the belt. And just when the spring is starting to stretch, that's when you can go over and then fine tune it with your tension with a knob on the side. Sparrow is exactly the same way. So it has an anchor for the tension belt here that you'll move to get the slack out of the belt, and the spring just barely starting to stretch. And then you've got the same knob and stalk design on this side to control your tension. So for a beginner on an e-spinner, there's only two things: speed and tension. And with the paperwork that I send with it, and the videos, and with the Facebook group, all the people helping you out, it's really easy to hit the ground running and get started. So you'll start out at probably about 35% speed, adjust the tension belt according to the video or the instructions, and take off and adjust it from there. I mean, literally, at festivals, I've taught people to spin in just a couple of minutes, and to where they could get into a nice groove with like a fingering or a sport weight single. So, okay. What battery would Sparrow use and what voltage? Sparrow is still a 15-volt motor. Will it run at 12 volt? I don't know. I haven't tested it. I designed it to run at 15, meaning that I can extract more power and torque out of the motor at 15 volts and actually operate it at a cooler temperature than I can at 12. So I like that. Now, if you drop it down to 12, it knocks off in that efficiency curve, and I can't tell you right now if that would actually be a problem for the wheel. So I have not tested it at 12 volts. These I have, And I'll say, don't run these at 12 volt. I don't like it at all. These are very, very technical wheels, very high performance. They really need that fuel. They need those 15 volts. This guy, it's not as big a deal, but where I haven't tested at 12 volts, I can't comment. So at 15 volts, it's going to run 2,000 RPM, bulk loads of power. All right. Ooh, am I done? You got any more? Oh, yeah, there's more. All right, a couple more. Will Sparrow work with a Magpie controller too? Yes, absolutely. The Magpie controller electronics is exactly the same as the Starling electronics. It's just in a different shaped housing so it can fit inside the Magpie. You can pop your Magpie controller out and plug the Sparrow straight into it, and it'll operate the exact same way. So yes, previous Magpie owners or previous Starling owners can purchase the wheel for just $400 and use your existing controller. Right. And his Raven flat pack, which I've already answered. That went behind there.
That went behind
You
there.
certainly did.
That's
You know what you get to do tonight.
You've
that's
got the
on-
long arms.
That's on me. Has any others popped up? How am I doing, guys? Do you love me yet?
Good.
Okay.
Studio audience.
Yeah.
Yay.
In the studio audience, we're getting good feedback.
There are three of us here watching Dave. I'm
Yeah.
over here making silent and gestures.
Oh, that's awesome. Yes. She's the whiny carry-on. Yeah.
It's like, look at the camera.
Right. So, you all, this has been wonderful. Anything else? If there's more questions, please ask them now. Or you can always, if you think of something later, if you want to put it down in this thread, I'll come back tonight and I'll answer them. And tomorrow, I got to work on this thing tonight. I'm trying to think what else I can say about them. I can't think of any questions that really haven't been asked. This was a good group of questions. And if I'm going to reiterate anything, how long have we been on? All right, right at an hour. If I can reiterate anything, I just want to get across to you guys how important Raven is to me, because it's what I've wanted to do the whole time. And I wasn't confident that I could produce a product that had the finesse and the ergonomics and the way that the spinner themselves, how they tune it in and how they dial it in, the control of that system, I was never happy with to turn loose. Could I have slapped an electromechanical solution on it and sold this thing 2 years ago? Yes, absolutely could. But it would have had tons of limitations, and I just couldn't do that. What my vision for how this thing was supposed to work is going to be achieved through microprocessor control. And I can't tell you how satisfying that is as a company. It's wonderful. And it spins great. It really does. It's awesome. Okay, so I'm going to turn everybody loose. Thank you for joining us. Happy holidays. I hope everybody gets to talk to their family or at least see them in a tiny little digital window. And I hope everything's going great for you guys. Everything's going great here. But I got to get off here and I got to go back to work. So, love you all and good night.